2 years ago, Toyota looked like the company that had completely misread the electric car revolution. Akiyo Toyoda, the grandson of the company's founder, was publicly questioning the rush toward battery-only vehicles while Tesla was dominating the conversation. Governments were setting aggressive electric deadlines, and almost every major automaker was promising that the internal combustion engine was headed for extinction. Critics called Toyota slow. Investors demanded answers. Environmental groups pushed back. Toyota eventually left the CEO position, and from the outside, the story seemed obvious. Toyota had resisted the future and lost. Then the story flipped. Because while everybody was arguing about whether Toyota had fallen behind, the company was building batteries, developing dedicated electric platforms, creating a new EV manufacturing operation, partnering with technology companies, and preparing a completely different attack. Then came the BZ5, an electric crossover launched in China with an entry price hovering around $18,000. Suddenly the company that supposedly missed the electric revolution was selling a modern EV for less than half the price of a Tesla Model Y in many configurations. And behind that affordable car sits an even bigger Toyota battery program, promising something potentially far more disruptive: solid-state technology targeting charging times around 10 minutes and ranges that could eventually stretch toward 1,200 kilometers. The important distinction is that the BZ5 itself does not have that futuristic solid-state battery. It uses proven battery technology supplied by BYD. But that may actually make Toyota's strategy more interesting, because Toyota is attacking the EV market in two directions at once. Affordable technology now, potentially transformational battery technology later. If Toyota can combine those two ideas with the manufacturing scale it already has, Tesla's biggest problem may not be another flashy startup. It may be the company everyone spent years calling too conservative. To understand why, you have to understand that Akiyo Toyoda was never really saying electric cars were useless. His argument was that forcing every customer, every country, and every type of vehicle into the same technological solution made no sense. Toyota is not a detached corporate executive who discovered automobiles in a quarterly earnings presentation. He has spent his life inside Toyota. He has even raced cars under a pseudonym to experience what his engineers were developing from behind the wheel. His position was straightforward. The actual goal should be reducing carbon emissions, not winning an ideological contest over which powertrain gets to claim victory. That difference became enormously controversial. While governments discussed restrictions on future gasoline vehicle sales and competitors raced to announce all-electric lineups, Toyota kept emphasizing what it called a multipathway strategy. Battery electrics would be part of the answer, but so would hybrids, plug-in hybrids, fuel-efficient combustion vehicles, and potentially hydrogen in applications where it made sense. That stance produced real pressure. A Danish pension fund controlling close to $20 billion in assets publicly challenged Toyota over what it viewed as an insufficiently aggressive EV position. Environmental groups targeted the company. Investors questioned whether management understood where the market was going. Eventually, Koji Sato became CEO, while Toyota moved into the chairman role. That transition was easy to frame as Toyota finally accepting that its old strategy had failed. Except Toyota did not abandon the strategy. It kept selling hybrids at enormous scale while simultaneously investing in the very electric technology critics assumed it was ignoring. Toyota was not refusing to enter the race. It was questioning when to accelerate, which customers were actually ready, and whether the technology being treated as inevitable was economically mature enough for the entire world. That philosophy makes much more sense when you rewind to 1997. Because Toyota had already made one enormous electrification gamble decades before Tesla became a household name. That was the year Toyota introduced the Prius, widely recognized as the first mass-produced hybrid passenger car. At the time, combining a gasoline engine with an electric motor and battery looked strange. Most manufacturers were still focused almost entirely on conventional gasoline and diesel engines. Toyota instead built a vehicle designed to use both systems where each worked best. Over time, that experiment became the foundation for an enormous product portfolio: Corolla Hybrid, Camry Hybrid, RAV4 Hybrid, Prius, and eventually electrified versions spread through Toyota and Lexus lineups across multiple segments. The logic was not particularly glamorous, but it was extremely practical. Toyota sells vehicles in wealthy cities with dense charging networks, but it also sells vehicles in rural America, developing economies, parts of Africa, Latin America, and huge sections of Asia, where dependable fast charging remains far less accessible. A battery electric vehicle can be fantastic when the owner has convenient charging. It can become much less convenient when that infrastructure does not exist. A conventional hybrid removes that dependency. The driver fuels the car like any other gasoline vehicle, while regenerative braking and the combustion engine help keep the smaller battery operating. Customers do not need to install a charger. They do not have to reorganize long trips around charging stops. Yet they can still substantially reduce fuel consumption compared with an equivalent gasoline-only vehicle. Depending on the model and driving conditions, improvements can be dramatic, often reaching the range of roughly 30% or more. More importantly, Toyota spent decades making those systems ordinary. Hybrid batteries proved they could last for years. Maintenance became familiar. Resale markets developed. Mechanics learned the technology. What started as something unusual became almost boring, and in the automobile business, boring reliability can be a massive competitive advantage. That decision also gave Toyota something critics frequently underestimated: volume. In 2024, Toyota's global group sales were around 10 million vehicles. Tesla delivered roughly 1.8 million. BYD's vehicle sales were far higher than Tesla's once plug-in hybrids were included, but Toyota still operated at an enormous global scale across powertrain types. That matters because the transition to electric vehicles is not simply a battery chemistry contest. It is a manufacturing contest, a sourcing contest, a distribution contest, a financing contest, a service contest, and eventually a cost contest. Toyota already knows how to build millions of vehicles, move them into markets around the world, supply replacement parts, support dealers, and maintain customer relationships for decades. The question was never whether Toyota understood mass production. The question was whether it could translate that machine into competitive electric cars. And while the company was being accused of ignoring batteries, it was pouring resources into one of the most difficult battery technologies in the industry: solid state. A normal lithium-ion battery uses a liquid electrolyte that allows ions to move between electrodes. Solid-state designs attempt to replace that liquid component with a solid electrolyte. In theory, that can unlock major benefits, including higher energy density, reduced fire risk, lower weight, and dramatically faster charging. In practice, manufacturing these batteries reliably and cheaply at automotive scale has been brutally difficult. That distinction matters because solid-state batteries have been described as the next revolution for years, and impressive laboratory results do not automatically become affordable cars. Toyota, however, has made unusually aggressive claims about where it believes the technology can go. The company has discussed future solid-state batteries capable of charging from low levels to around 80% in roughly 10 minutes under ideal fast-charging conditions, while delivering driving ranges potentially approaching 1,200 kilometers or roughly 750 miles depending on test methodology and vehicle configuration. If Toyota can actually commercialize anything close to those numbers at meaningful scale, the psychological barrier around EV ownership changes immediately. Charging starts to feel more like stopping for fuel. Range anxiety becomes dramatically less relevant. Automakers can potentially use smaller packs for conventional range vehicles, reducing weight and material costs, or use larger packs to create long-distance cars that current lithium-ion products struggle to match. That is the dream, but there is an important reality check. Toyota still has to manufacture the technology in huge quantities, prove durability, keep defect rates low, secure materials, and reach a cost customers can afford. Until those things happen, solid state remains a promise rather than the reason you should buy a Toyota EV today. And that brings us to the fascinating part of the strategy. Toyota is not waiting for solid state before entering the affordable EV fight. It is using technology that already works. Toyota created a dedicated operation focused on next-generation battery electric vehicles and has been developing production methods using automation, robotics, and digital manufacturing tools to reduce complexity. It has also built dedicated electric architectures under its broader ETNGA development approach rather than treating every EV as a gasoline vehicle with batteries inserted afterward. Dedicated architectures matter because batteries fundamentally change vehicle packaging. The pack sits low in the floor. Motors take up less space than combustion engines. Weight distribution changes, crash structures change, cooling requirements change, interior packaging can change. When engineers design around those realities from the beginning, they get more freedom to optimize efficiency, space, safety, and manufacturing cost. Toyota has also been expanding its software and electronics capabilities while working within Japan's enormous technology ecosystem, including relationships involving companies such as Panasonic and Denso. This remains one area where Tesla has a genuine advantage. Tesla designed its vehicles around software, centralized computing, connected services, frequent over-the-air updates, and a direct digital relationship with customers. Traditional manufacturers have spent years trying to recreate that experience while managing more complicated supplier networks and legacy electrical systems. Toyota still has work to do there. But software leadership does not erase Toyota's strengths in manufacturing discipline, quality control, supplier management, and global distribution. The real question is what happens when a company with Toyota's industrial machine gets an electric platform good enough that buyers stop caring who arrived first. The BZ5 gives us an early answer. Toyota introduced the BZ5 in China in 2025 as a sleek electric fastback crossover positioned aggressively on price. Depending on trim and pricing conversions, the entry point landed around the equivalent of $18,000, with some references putting it close to $17,999. That number is the headline because it completely changes the comparison. A Tesla Model Y sits in a much higher price category in most markets, so Toyota is not trying to win by building a slightly cheaper imitation of Tesla. In China, it is entering a brutal market where domestic brands have pushed EV technology and pricing forward at astonishing speed. To survive there, Toyota needed something far more competitive than an expensive compliance vehicle carrying a familiar badge. The BZ5 uses a battery supplied by BYD, which is one of the most revealing details in the entire story. Toyota and BYD are competitors, but they are also willing to cooperate when each company possesses something the other needs. BYD's lithium iron phosphate blade battery technology is known for emphasizing safety, durability, cycle life, and lower dependence on expensive nickel and cobalt chemistry. It does not offer the extraordinary charging or range claims associated with Toyota's future solid-state work. That is precisely the point. Toyota is not pretending futuristic batteries are already here. For an affordable vehicle today, it is using mature LFP chemistry from one of the strongest battery manufacturers in China. The BZ5 can offer practical charging performance, contemporary range, and competitive pricing without waiting for a scientific breakthrough. Inside, Toyota has not treated the low starting price as permission to build a stripped-out economy box. The vehicle includes the kind of digital experience Chinese EV customers increasingly expect: large-screen infotainment, a digital instrument interface, connected features, voice functions, mobile integration, over-the-air update capability, and advanced driver assistance technology depending on specification. Safety equipment includes features such as multiple airbags, automatic emergency braking, and lane support systems. Visually, it also avoids looking intentionally cheap. The body has slim lighting, smooth surfacing, and a sloping roofline designed to place it closer to fashionable crossover territory than traditional budget transportation. That matters because low-priced vehicles only disrupt premium competitors when customers feel they are getting a bargain rather than accepting a punishment. Toyota is effectively saying the affordable EV does not have to look like the vehicle you bought because you could not afford the one you wanted. And that is where the Tesla nightmare part of this story starts becoming more credible, with one massive qualification. You cannot currently walk into an American Toyota dealership and buy a BZ5 for $17,999. The car was launched for China, where pricing, supply chains, labor, local competition, battery sourcing, incentives, and manufacturing economics are completely different from those in the United States. BYD-linked components also collide with an increasingly complicated trade environment in Western markets. Tariffs and regulatory policies can radically alter the economics of exporting Chinese-built electric vehicles. So anyone claiming Toyota has effectively placed an $18,000 Tesla killer in American showrooms is getting ahead of reality. That is not what happened. What happened is potentially more important strategically. Toyota demonstrated that it can participate in the extreme price competition happening inside the world's most aggressive EV market. China is where Tesla faces some of its strongest competition, not only from BYD, but from a growing field of companies delivering long feature lists at prices that would have seemed impossible a few years ago. Toyota once looked vulnerable in exactly that environment. The BZ5 shows that it is willing to adapt, localize, share technology, and sacrifice the pride of doing everything internally if collaboration produces a better product. If that formula succeeds, Toyota can take what it learns in China and adjust it for other markets rather than forcing one globally identical car into completely different economic realities. Toyota has already spent decades building factories, suppliers, sales organizations, finance operations, and service networks across North America, Europe, Asia, Africa, Latin America, and the Middle East. Tesla had to construct a global production network at extraordinary cost because it started with almost none of that infrastructure. BYD is now expanding aggressively outside China and building factories in new markets, but that international presence is still developing. Toyota begins with the opposite problem. The infrastructure exists. The challenge is filling it with the right electric products at the right moment. That becomes especially important because the broader EV market has not followed the smooth adoption curve many companies predicted. Manufacturers invested billions assuming battery electric demand would rise at almost any price. Then buyers became more selective. Some EV programs were delayed. Production plans changed. Inventories increased in certain markets. Ford acknowledged enormous losses inside its electric vehicle business while adjusting F-150 Lightning production. General Motors revised the timing of electric programs, including plans around electric pickup capacity. Lucid and other dedicated EV manufacturers have repeatedly had to balance ambitious expansion plans against difficult economics. None of this means electric vehicles are disappearing. Global EV sales continue to represent a major and growing part of the automobile market. What it does mean is that the transition is messy. Customers care about purchase price, charging access, insurance, depreciation, road trip convenience, reliability, and resale value, not just whether a drivetrain produces zero tailpipe emissions. Toyota's hybrid-heavy strategy protected it from betting everything on one adoption timeline. Now those hybrid profits and decades of electrification experience give the company room to enter full EVs more aggressively as battery economics improve. This is also why Toyota's brand reputation matters more than the specification sheet suggests. Tesla earned enormous loyalty by making electric cars desirable rather than merely environmentally responsible. It proved people would buy EVs because they were quick, technologically exciting, and different. BYD then demonstrated how violently costs could fall when battery production, vehicle engineering, and manufacturing were integrated at enormous Chinese scale. Toyota brings a third kind of advantage: familiarity. There are millions of buyers who do not want to be early adopters. They do not want to explain software bugs to customer support, study charging curves, or gamble on an unfamiliar service network. They want something that behaves like an appliance, start every morning, survive abuse, receive parts easily, and still be worth something years later. Toyota has spent generations building exactly that expectation. Of course, reputation alone will not protect it. Tesla still has major advantages in software integration, charging experience in key regions, powertrain efficiency, brand recognition in EVs, and real-world data gathered from a massive connected fleet. BYD has extraordinary command over battery supply and low-cost manufacturing. Chinese manufacturers iterate at a speed that can make traditional automotive development cycles look painfully slow. Toyota cannot simply attach its badge to an average electric car and assume customers will reward it. The BZ5 matters because it suggests Toyota understands that. Price has to be aggressive, technology has to feel current, battery sourcing has to be pragmatic, and future breakthroughs such as solid state have to become manufacturable products rather than permanent demonstrations. That is why Akiyo Toyota's controversial position looks different today than it did during the peak of the EV hype cycle. He was not necessarily predicting that battery cars would fail. He was arguing that the transition would happen differently across markets and that automakers should reduce emissions without assuming every customer could make the same technological jump at the same time. Toyota used hybrids to bridge that gap, preserved enormous global volume, and kept investing in batteries while competitors spent aggressively to establish EV capacity. Now it is entering the market from a position few companies possess. It can sell hybrids to customers who are not ready for charging, conventional EVs such as the BZ5 where price and infrastructure make them attractive, and potentially solid-state vehicles later if the technology finally reaches mass production. That is not one bet, it is a portfolio of bets. And the biggest threat to Tesla is not that Toyota suddenly invented a magical $18,000 car that immediately replaces the Model Y. The threat is that Toyota may have found a path toward making electric vehicles ordinary. Once an EV becomes just another dependable Toyota sitting beside a Corolla, Camry, or AAV4, the conversation changes. Buyers stop asking whether they are ready to join the electric revolution and start asking which powertrain saves them the most money. That is a far more dangerous battlefield for any company accustomed to charging a technology premium. If Toyota can eventually combine BZ5 level affordability, globally competitive software, its reliability reputation, and solid-state charging performance anywhere close to the numbers it has discussed, then Tesla and BYD will face a competitor with something neither can easily manufacture overnight: Toyota's worldwide footprint. But there are still enormous unanswered questions. Can Toyota produce solid-state batteries cheaply enough? Can it match Chinese development speed? Can it make its software experience competitive with Tesla? Can an $18,000 China market EV translate into similarly disruptive pricing elsewhere after tariffs, local manufacturing costs, and regulations are included? Nobody can answer those questions yet, and that uncertainty is what makes this story worth watching. Toyota spent years being criticized for moving too slowly, but moving slowly only becomes a mistake if you arrive too late. If patience allowed Toyota to preserve profits, learn from hybrids, wait for battery costs to fall, partner with companies like BYD, and enter the market with better economics, then what looked like hesitation may turn out to have been preparation. Tesla proved the electric car could be exciting. BYD proved it could become brutally affordable. Toyota is now trying to prove it can become normal everywhere, and if the company that sells roughly 10 million vehicles in a year gets that formula right, the next phase of the EV race may not be decided by who started first. It may be decided by who can convince the next 100 million drivers that switching requires no sacrifice at all. So what do you think? Was Toyota genuinely behind and finally forced to catch up, or was Akiyo Toyoda's slower multipath strategy the smarter move all along? And if Toyota eventually delivers fast-charging solid-state technology at mass market prices, would you choose it over a Tesla or BYD? That is the argument worth having, because the $18,000 BZ5 is not the ending of Toyota's EV story. It may be the moment the real fight begins.